The baseline kind of assumption is we go to E2AS1, take the prescriptive details, copy paste, try to massage them to make them work. But what we do is allow people to use whichever assembly, whichever component, and detail it in a way that looks a certain way, and we make sure that it's still going to be durable, robust, watertight, shed all the things away, but we don't have to follow those prescriptive details. We get a little bit more flexibility, which is pretty cool.
Yeah, you have to agree what good looks like.
Sure.
Right? The building code is the worst thing you can build.
Legally, the worst thing.
It's
yeah.
like the worst building you could think of.
A lot of people think of the building code as this like shining, if I do the building code, it's going to be great. But it's literally the worst legal thing that you're allowed to build.
When you actually understand the science behind it, then you can actually make really robust decisions. And maybe you do end up back at what you always do, but at least you got there from an informed way.
Yeah, exactly.
You got predictive models. You've got testing ways to test things. You've got all these tools you can use to
make an informed decision.
Yeah.
Yes, yeah.
Yeah. You don't have to wait for failure
to
make a change.
Absolutely. You can do the science first, do the research first, and then come up with a design that makes sense.
That's right.
Yeah. And I guess that's what building science is. It's looking at the materials, looking at the variables on a building, and then designing the right thing. And I think the key funky thing is that there's not necessarily one right answer. There's probably 3 different opinions between the two of us, and any number of things can change how all of the components come together.